If you've already learned how to solve a 3x3 Rubik's Cube, how many steps does it take to learn the 4x4? The answer is just 2 steps. First, reduce the 4x4 into a 3x3, then solve it using the 3x3 method. In this video, you'll learn the basic 4x4 solving method, called the reduction method. As the name suggests, it means reducing a 4x4 into a 3x3. If you don't have a 4x4 yet, or you're worried yours might be defective, click the link in the lower left corner of the video, or the pinned comment to get one before continuing. Before we begin, here's a quick reminder. Try not to pause halfway through and start solving immediately. Watch the entire tutorial first, then practice afterward. Once you have a scrambled 4x4, our first goal is to make the center pieces on all 6 faces the same color. For example, let's look at the top face. The center consists of 4 pieces: white, green, yellow, and red. We want all 4 to become the same color. Let's assume this face should be all white. So, how do we build the white center? Place the target face on top. Then look for a white center piece on the front. Luckily, there's already one here. To move it up, we'll use our familiar algorithm. Hook, up, back, down. However, on a 4x4, the up move turns both right layers upward together. The back move stays the same, and down turns both right layers downward together. After performing hook, up, back, down, the white piece moves from the front to the top. Now we need 2 more white pieces. Let's rotate the cube and look for them. None here. None on this face either. Ah, here's one. Can we use the algorithm now? Not yet. There's one important rule. The target piece must be in the upper right corner. If it isn't, rotate it into place. Also, on the top face, the lower right position must not be white. Once both conditions are met, you can start the algorithm. For example, the front upper right is already white, but the top lower right is also white, so rotate the top until it isn't. Then perform hook, up, back, down. The piece is solved. Always remember these 2 conditions. Let's keep searching. There are no more white pieces on these faces. So, where's the last white piece? Some of you have probably guessed. The last white center piece must be on the bottom. Bring the bottom face to the front first. Check whether the piece is in the upper right corner. Right now it's in the lower right, so rotate it into the upper right position. Then return that face to the bottom. Again, make sure the top position isn't white. Now the white piece will skip over the front face and go directly to the top. So the algorithm changes slightly. It becomes hook, up, up, back, down, down. Whenever a bottom piece has to skip one face, use hook, up, up, back, down, down. Now the white center is complete. Now think about it. On a 3x3 Rubik's Cube, what color is opposite the white center? It's yellow. Now place the completed white center on the bottom. Then build the 4 yellow centerpieces on the top. The principle is exactly the same. The algorithm is the same as well. Look for a yellow centerpiece on the front. For example, I have two here, so I'll just pick one. I'll use this one. Move it to the upper right corner. At the same time, make sure this top position isn't yellow. It isn't yellow. This one is yellow. Now perform hook, up, back, down. That piece is solved. There's another one on the front, so we do the same thing. Place it here and make sure this spot isn't yellow. Then do hook, up, back, down. Now the pieces are solved. There's no yellow on this face, so rotate the cube. Here's one already in the upper right. Make sure this position isn't yellow. Then perform hook, up, back, down. Now we have 3, rotate again. Nothing here. Here's one. Move it to the upper right. Make sure this position isn't yellow. Then perform hook, up, back, down. Now all 4 centerpieces on the yellow face are yellow. The white center is complete as well. So both the white and yellow centers are finished. Next, we'll start solving the 4 side centers. As you can see, they're still scrambled. Place the white and yellow centers on the left and right sides. Now let's pick one side to solve. Let's make this one blue. I like blue the most, so I'll choose this face to be blue. This face already has one blue centerpiece, which saves us some work. There's another blue piece on the front. Move it to the upper right corner. Make sure this top position isn't blue. Then perform hook, up, back, down. Now we have 2. There's no more on this face, so rotate. Here's another one. Again, place it in the upper right and make sure this position isn't blue. Then perform hook, up, back, down. Now we have 3. The last blue piece must be on the bottom. Bring the bottom face to the front first. Move the blue piece into the correct position. Then return it to the bottom. Adjust the top as well. Make sure this position isn't blue. Remember, I explained this earlier. This piece has to skip over the front face and go directly to the top. It goes straight from the bottom to the top, so the algorithm changes. It becomes hook, up, up, back, down, down. Now the blue center is complete. After finishing blue, place it on the bottom. Does anyone know what color should be on top now? That's right, the top should be green. Some of you may wonder, how can I remember that blue is opposite green? Just grab a 3x3 cube. When blue is on the bottom, green is on the top. You can always compare it with a 3x3 if you're unsure. Now that we're solving green, there's a green piece on the front. Just like before, move it to the upper right. Make sure this position isn't green, then do hook, up, back, down. Now we have 3. Rotate it until you find the last green piece. Position it correctly, adjust the top, then do hook, up, back, down. The green center is complete too. Now you'll notice that the white, yellow, blue, and green centers are all finished. Only to remain. The last 2 are also the hardest. Pay close attention because this is where mistakes are most common. Let me give you an example. Suppose we finished the first 4 centers. After solving white, yellow, blue, and green, we notice this face already has 4 orange centerpieces, and the bottom already has 4 red centerpieces. Does that mean they are automatically correct? Not at all. We know the white, yellow, blue, and green centers are correct, but the final red and orange centers must always be checked. For example, take a 3x3 cube. Hold the white face on top and the blue face in front. On the 3x3, the left side is red. But what color is it on this 4x4? It's orange, which means this position is incorrect. Even though they're all orange centerpieces, they should actually all be red centerpieces. So what should we do? How do we fix this? It's simple. Just solve them one centerpiece at a time. Let's look at the red center. Place a red centerpiece in the upper right position. Make sure this position is not red, then do hook, up, up, back, down, down. This moves one red centerpiece into the top face. Then here's another one. Do hook, up, up, back, down, down again. Now we have two red center pieces. Next, over here. This position won't work. Move it to the upper right corner. At the same time, make sure this spot isn't red, since it's jumping over one face from the bottom. We use hook, up, up, back, down, down. Now we have three center pieces. Just one more to go. Adjust it, then do hook, up, back, down, down. There we go. We've changed all four orange centers into red ones. Of course, this is a rather extreme example. You probably won't run into this exact situation. The main point I want to demonstrate is that your completed center colors must match a 3x3 cube exactly. Let's compare them now. White on top, blue in the front, red on the left, orange on the right, green in the back, yellow on the bottom. They match perfectly. Only then have you solved the 4x4 center pieces correctly. If your centers don't match a 3x3, the color arrangement is wrong. That means you made a mistake. While solving the last two centers, you probably identified them incorrectly. Be sure to watch out for that. That wraps up the lesson on solving the 4x4 center pieces. Now it's your turn to practice. In the last lesson, we solved the 4x4 centers. Now let's see what's still different between the 4x4 and the 3x3. After a snap, doesn't this cube look just like a 3x3 now? Let's look at this face. The center is yellow, and the edge is also yellow. The only difference is that the 4x4 edge looks longer. That's because it's made of two matching edge pieces. The same goes for blue, orange, and green. The corner pieces are the same too. White, white, green, blue. This face is exactly the same. Let's check another face. It's identical as well. At this point, we can say the 4x4 has been successfully reduced. It has effectively become a 3x3, just a little thicker. By now, everyone should understand. After solving all the center pieces, our next goal is to pair up every two matching edge pieces. For example, this yellow-blue edge and this yellow-blue edge. Combine to form one complete yellow-blue edge. Our next goal is to pair up all the edges like this. Let's use the white-orange edge as an example. Here's one white-orange edge, and here's the matching one on the other side. Once they're positioned like this, we only need one algorithm. Let's try it. First, turn the top two layers to the right. That's a double layer turn, then do hook, up, back, down using a single layer. Then lift one layer. Hook. Press. Then return the top two layers. Now the two matching edge pieces are paired together. They become one complete white-orange edge. Amazing. Some of you may wonder, what if my pieces aren't already on the left and right? Let's use this white-green edge as an example. Here's one white-green edge, and here's the matching one. Right here. Since it's on the top layer, we want them positioned left and right. This one is already on the left, so rotate the other one to the right. Then turn it down into the middle layer. Now, the white-green pair is left and right. At this point, turn the top two layers to the right. Hook, up, back, down. Lift, hook, hook, press. Turn the top two layers left. Now the two white-green edge pieces are paired together. Let's look at another example. This time, let's use a more extreme case. Suppose we have a yellow-orange edge piece here. The matching yellow-orange edge happens to be right here. Let's change the situation a little. Like this. We found the first yellow-orange edge and placed it on the left. The second one is over here. We first move it to the right, because this one is on the left, so it has to go to the right first. Then bring it down. After that, you'll notice these two pieces are on the left and right. But they're not on the same layer. One is on the second layer and one on the third. In other words, they aren't aligned. So what should we do? Just remove the first and last moves from the pairing algorithm. Simply do hook, up, back, down. Lift, hook, hook, press. Now, the two pieces become aligned. They're both on the third layer. Now what do we do? Turn the top two layers. Hook, up, back, down. Lift, hook, hook, press, then turn the two layers back. Now they're paired together. Every edge is solved in basically the same way, as long as you find two matching edge pieces, one on the left and one on the right. You can use this algorithm. Some of you may wonder, what if the two edge pieces are already on the left and right? Like this yellow-green edge on the right, and this one on the left, but they are both in the lower position. Can we still do it? Yes. The algorithm stays the same. Turn the top two layers right, then hook, up, back, down. Lift, hook, hook, press. And return the two layers to the left. The paired yellow-green edge will appear on the left. Right over here. As you keep repeating this process until every edge is paired, your 4x4 will effectively become a 3x3. And you can solve it just like a normal 3x3. Let's look at one more example. Here's a green-orange edge. We'll place it on the left. The matching one is here. Some people ask, why are your examples always on the top layer? Can't it be on the bottom? Of course it can. Let's see. Suppose this green-orange edge is here, and the matching one is on the bottom. Since this one is on the left, move the other one. Without moving this one, rotate the other edge to the right. Then make one upward turn. Now they're on the left and right. Just check whether they're on the same layer. These two are. If you ever get this situation, where they're left and right but not on the same layer, simply do this on the right side. Hook, up, back, down. Lift, hook, hook, press. Now they're on the same layer. Once they're aligned, use the pairing algorithm. Turn the top two layers right. Hook, up, back, down. Lift, hook, hook, press. Turn the two layers left. Now it's paired on the left. Amazing. That's how you pair the edge pieces on a 4x4. I think it's actually much easier than solving the center pieces from the previous lesson. Now it's time for you to practice. Hello everyone. In this video, we'll learn the two special cases you may encounter on a 4x4 cube. After reducing the 4x4 in the previous lesson, we can basically treat it just like a 3x3 cube. However, some of you may find that during the solve, you'll run into special cases that can't be solved by normal 3x3 methods. Today we'll cover those. Once the reduction is complete, solve the cube normally. For example, first make the white-yellow daisy. Some of you may use a different 3x3 solving method than mine. But regardless of the method, you'll eventually reach the same stage. Solve the 4x4 just like a 3x3 and complete the first two layers. At least during the first two layers, you won't run into any special cases. You can solve them normally without any trouble. I won't waste any time here. I'll solve the first two layers directly. Once they're finished, the first special case appears when making the yellow cross on the top layer. Take a look at this case. We have one yellow center and one yellow edge, but the others aren't yellow. On a 3x3, this pattern can never appear. Normally there are only 3 yellow cross cases: the dot, the L shape, and the line. This isn't any of them. Let's try the normal cross algorithm first. Down, hook, up, return, down, lift. Now we have one center and 3 yellow edge pieces. The last edge is flipped incorrectly. The normal method can't fix it. We need a special algorithm for this case. This case is called OLL parity, so we use the parity algorithm. Let's do it. Keep the flipped edge facing you. Then perform. Turn the to right layers up. Hook twice. Rotate the whole cube upward. Turn the to right layers up and hook twice. Again, to right layers up, hook twice. Turn the to right layers down. Hook twice, turn down, hook twice. Continue the algorithm until the parity is solved. Now the yellow cross is complete. That's the first special case, OLL parity. Next, continue solving the yellow face normally. Then solve the headlights. I'll skip ahead and finish them. After that, you may encounter another special case. Two side faces are already solved, like the red and orange faces here. But the blue and green faces are not. Sometimes it could be red and blue solved instead, with orange and green unsolved. That's also possible. This never happens on a 3x3, it's called PLL parity. On a normal 3x3, either all four sides are incorrect, or only one side is correct. This is different. So, let me demonstrate the PLL parity algorithm. Here's how it goes. Turn the inner right slice up twice. Hook twice. Turn the inner right slice twice again. Hook twice with the top two layers. Turn the inner right slice twice. Then hook twice with both the top and inner layers. That fixes the parity. Now the cube is solved. Some of you may ask, what about the other case? Let's look at this example. The headlights are solved. The red face is solved, and the green face is solved. Orange and blue aren't. The previous case had opposite faces, this time they're adjacent. For this case, put either incorrect face in front. Then perform the PLL parity algorithm, up twice. Hook twice. Up twice with two layers, hook twice. Up twice with two layers, hook twice. After the algorithm, it becomes a normal 3x3 PLL case. Now only one side is solved, while the other three are not. That's a standard 3x3 situation. So, you can simply finish the cube using your normal 3x3 solving method. This is the final lesson for solving the 4x4. Please like, share, and send it to friends who haven't learned 4x4 yet. If you've successfully solved your 4x4, take a photo of it and post it in the comments. Thanks for watching, and see you in the next video. Bye. Like and follow. Let's get straight into the tutorial. First, scramble the puzzle. Now let's learn how to complete our first goal. It's called the 3-diamond pattern. The 3-diamond pattern. The first step is extremely simple. I'll go through it quickly. After picking up the puzzle, align the colors of all 4 tip pieces. Just like this. Align this one as well. If one turn doesn't work, turn it again. If it still doesn't match, turn it once more. There we go. Once all 4 tips are aligned, choose one color to solve. For example, I'll solve the green side. Find the corner piece that does not contain green. Take a look. This corner has green, yellow, and blue. Since it has green, we don't want it. This one has yellow, red, and blue, so it doesn't contain green. Whenever you solve a color, find the corner that doesn't contain that color. If you solve red, find the corner without red. If you solve green, find the corner without green. If you solve blue, find the corner without blue. We're solving green, so use the corner without green. Move that corner to the back. Just place it at the back like this. Now you'll notice that there's a yellow diamond here, another yellow diamond here, and a blue diamond here. Our goal is to make 3 green diamonds on the front face. If this isn't green, just rotate it. Not yet, rotate again. There it is, a green diamond. That's 1 green diamond. If this one isn't green, rotate it. If needed, rotate it once more. Now it's green. Do the same for this one. Just rotate it. Okay, at this point, the 3 corner pieces and the 3 center pieces are all solved. Sometimes you'll see 2 extra green pieces here. That's fine. Most of the time, it will look like this instead, without those extra green pieces. Usually, this is what your solved pattern looks like. Of course, if these 3 spots are also green, that's even better. It doesn't matter if they aren't, as long as you've completed these 3 diamonds. The first step is complete. Next, we'll solve the entire green face. Place the 3 solved diamonds at the bottom. Any face can be placed at the front. Now look at the small top pyramid. This is the whole pyramid. And this is the small top pyramid. Find a green edge piece in this top layer. Let's use this one. Besides green, it also has blue. First, make sure the green sticker faces you. It can be on the left or the right. Here it's on the right. Notice the side color is blue. Rotate only the bottom until these 2 diamonds become blue. Now both diamonds are blue. Now we can insert the green piece using an algorithm. How? The algorithm is down, down, up, up, down, down, up, up. Since the green piece is on the right, start with the right side down. Right down, then left down. Right up, left up. Now the green piece is solved. Not only is the green piece in place, the blue side is also perfectly aligned. So this edge is completely solved. Now let's find another green piece in the top pyramid. For example, this one. It's on the right again. Check the other color on the piece. It's red. This edge has 2 colors, green and red. Rotate the bottom until these 2 diamonds become red. Again, leave the top still and turn the bottom. Now the 2 diamonds are red. Now perform the algorithm. It's still on the right. So, right down, right up, left up. Now this piece is solved. As you can see, everything is neat and perfectly aligned. Now let's continue looking for another small green piece on the top. Oh, we can't find one. What should we do? It may already be solved or maybe not. We can see the only green piece is down here at the bottom. Simply bring it to the front and perform. Down, down, up, up. Now this position is solved. This solves the problem of not finding a green piece in the top layer. Now we can find one again, right? Before that, let me show you another case. So far, every piece has been on the right. Let's try a different example. Suppose we find this piece. When the green sticker faces us, it's on the left. Previously, they were all on the right. This one is on the left. Its side color is yellow. So these 2 bottom diamonds must become yellow. Turn once. If it's not correct, turn again. Now both diamonds are yellow. Then perform down, down, up, up. Since the green piece is on the left, start with the left side. Left down, left up, right up. One algorithm, and it's solved. Now the entire green face is complete. Notice how neatly the side colors are lined up. This side is all yellow. This side is all red, and the green face is completely solved. Alright. Once the green face is solved, step 2 is complete. Now let's move on to step 3. Step 3 is solving the entire pyraminx, and it's actually very simple. If the puzzle isn't solved after completing the green face, just solve a different face. Forget about green now. Choose another color. Let's use red. First, make the 3 red diamonds. Align the red diamonds, then place the red face at the bottom. Now, look for a red piece on top. If you can't find one, it must be at the bottom. If so, perform down, down, up, up. Either hand can start. After that, you'll definitely find a red piece on top. Check its side color. It's yellow, and the 2 bottom diamonds are already yellow. So perform down, down, up, up. Now the red face is solved. Not only is the red face solved, the side colors are also perfectly aligned. If yours looks like this, you've done it correctly. If the puzzle still isn't solved, then red isn't the answer either. Let's try another color. This time, we'll use yellow. First, make the 3 yellow diamonds and place them at the bottom. Sometimes after solving red, it may look like this. If yellow doesn't already have 3 diamonds, don't flip it over yet. Make the 3 yellow diamonds first. Now find a yellow piece. The yellow sticker faces us, and the piece is on the left. The side color is blue, and the bottom diamonds are blue. So use the left-hand algorithm, left down, left up, right up. Now another yellow piece appears. Check its side color. It's green, the green diamonds are here, and the piece is on the right. So use the right-hand algorithm, right down, left up, left up. Now the yellow face is solved. Take a look. Everything is solved. Everything is complete. So once you know how to solve one face, you can always solve the entire pyraminx. If solving one face doesn't finish the puzzle, just switch to another face. If it's still not solved, switch to another color. Keep doing this until the whole puzzle is solved. And that's the complete pyraminx tutorial. That's all for today. See you in the next video. Bye everyone. If you've already learned how to solve a 3x3 cube, how many steps does it take to learn how to solve a 4x4 cube? The answer is just 2 steps. First, turn the 4x4 cube into a 3x3 cube. Second, solve it using the 3x3 method. In this video, we're going to learn the basic method for solving a 4x4 cube. It's called the reduction method. As the name suggests, we reduce a 4x4 cube into a 3x3 cube. If you don't have a 4x4 cube yet, or you're worried that the one you have might be incorrectly assembled, you can click the link in the bottom left corner of the video or the pinned comment. Get a cube and then continue learning. Before we officially start the tutorial, let me give you a quick reminder. Try not to stop halfway through the video and start solving along with me. It's better to watch the entire video first and then start practicing. Once you have a scrambled 4x4 cube, our first goal is to make the center pieces on all 6 faces. Same color on each face. Let's take a look at this 4x4 cube. For example, let's look at the top face. Center actually consists of 4 pieces, and right now they may all be different colors, right? We have white, green, yellow, and red. We want all 4 pieces to be the same color. In other words, they should match. Let's assume that this face is supposed to have 4 white center pieces. So let's start solving the white center. How do we do it? First, put the face we're solving on top. Then look at the 4 center pieces on the front and see if there's a white one. Luckily, in my case, there is one right here. We already have a white piece here. So how do we move this piece into place? We'll use our old friend, the RU sequence. However, on a 4x4 cube, the RU sequence is slightly different. Let's take a look. The R move is still the same. The U move becomes turning the 2 right layers upward together. The R move is still the same. And the U move becomes turning the 2 layers downward together. Now, after doing RU, you can see that the white center piece that was in front has moved to the top. Great, we still need 2 more white pieces, so let's rotate the bottom and look around. Let's rotate the whole cube to search for them. There isn't a white center piece on this front face. And there's none on this face either. Oh, this face has one, right here. And we simply do you to move this piece into place. Actually, not yet. We need to follow a certain rule or requirement. White center piece we want on the front must be positioned in the upper right corner. If it isn't, rotate the cube like I just did. There must be a white piece in the upper right corner, while at the same time, lower right corner, and viewed from the top. This is the lower right corner. Must not be white. Once these two conditions are met, we can do the algorithm. If they're not, simply rotate the cube. For example, suppose we have this situation. Front upper right corner is already white. The upper face's lower right corner is also white, so we need to rotate it. Make sure this position is not white. Once these two conditions are satisfied, we can do the algorithm. U. And now the piece is in place. Remember, these two conditions are important. Okay, let's keep looking. Oh, none of these faces have any white pieces left. There are no white pieces here either. So now, where do you think the last white piece is? Some of you clever viewers have probably already guessed it. The last white piece must be on the bottom. Some of you may be wondering, how do we solve a piece that's on the bottom? First, bring the bottom face to the front. Check whether this piece is in the upper right corner. As you can see, it's currently in the lower right corner, so let's rotate it. Move it into the upper right corner. Once it's in the upper right corner, we move this face back to where it was originally. It was on the bottom, so put it back on the bottom. Same rule still applies on top. This position cannot be white, so rotate it until it's not white. Now you'll see that this little white piece basically skips over the front face and goes directly to the top. So our U sequence changes slightly. It becomes R, U, R, U. In other words, when a piece on the bottom needs to cross over one face and move to the top, the algorithm becomes R, U. And with that, we've completed the white center. All four center pieces are now the same color. Now, think about this for a moment. What color is opposite the white center on a 3x3 Rubik's Cube? The opposite color is yellow. Now we can move the completed white center to the bottom. Then we make for yellow center pieces on the top. The principle is exactly the same. And the formula is exactly the same. Let's look for yellow pieces on the front. For example, I have two here, so I'll just choose one. I'll choose this one. Put it in the upper right corner. At the same time, make sure this position on top is not yellow. This one isn't yellow. This one is yellow. So we do right, up, left, down. And this piece is solved. If there's another one here in front, we do the same thing. Put it here and make sure this position is not yellow. And do right, up, left, down. Two pieces are solved very quickly. There are no more yellow pieces on this face, so we rotate the cube. There's one here, right in the upper right corner. Make sure this position is not yellow. And do right, up, left, down. Now we have three pieces solved. Rotate again. No yellow piece here either. Rotate again. There's one here. Put it in the upper right corner. Make sure this position is not yellow. And do right, up, left, down. Okay. Now you can see that all four pieces on the yellow face are yellow. White center is also solved. So the white and yellow centers are both solved. Next, we need to solve the centers of the four side faces. As you can see, the four side faces are still all mixed up. Put the white and yellow center faces on the left and right sides. Next, let's choose any face and solve the blue center. Let's solve blue. I personally like blue. I'll just choose this face to be blue. This face already has one blue center piece. That saves us a little work. There's also one blue piece on the front face. Move it to the upper right corner. The position above it must not be blue. And do right, up, left, down. Now we have two. There are no more here, so let's rotate. There's one here. You do the same thing, put it in the upper right corner and make sure this position isn't blue. And do right, up, left, down. Now we have three pieces. And the last blue piece. Last blue piece must be on the bottom. It's right here. First, bring the bottom face to the front. Then move the blue piece into the correct position. And put that face back on the bottom. We also need to adjust the top. Make sure this position is not blue. You remember, I just explained this, right? This piece needs to skip the front face and move directly from the bottom to the top. It moves directly from the bottom to the top, so the formula needs to change, right? Formula becomes right, up, left, down, down. And there we go, the blue center is solved. Now that the blue center is solved, put blue on the bottom. Does anyone know what color should be on top after putting blue on the bottom? That's right, it should be green. Some of you might ask, how am I supposed to remember that? How do I know that green is opposite blue? You can simply take a 3x3 Rubik's Cube and check. If blue is on the bottom, green is on top, right? You can take out a 3x3 cube from time to time and use it as a reference. Okay, since we need to solve green on top, we have our green piece here on the front. Do the same thing. Put it in the upper right corner. Make sure this position isn't green. And do right, up, left, down. That's 3. Let's rotate and find the last green piece. Put it here and adjust it. And do right, up, left, down. The green center is solved too. Now we can see that we have solved the centers of 4 faces: white, yellow, blue, and green. Only 2 faces are left. And this is the hardest part. Pay close attention because this step is very, very easy to mess up. Let me give you an example. For example, suppose we have finished front for centers. After solving the white, yellow, blue, and green centers, I noticed that this side is already solved. It has 4 orange center pieces, and the bottom also has 4 red centers. So can we just leave it like this? Isn't it already solved? Not at all. You know the white, yellow, blue, and green centers we solved are correct. For the last 2 colors, red and orange, we absolutely need to compare them with another cube. For example, let's take the white side we solved. Take a 3x3 Rubik's Cube, put white on top on both cubes, and blue in front on both cubes. Now look at the left side of the 3x3 cube. It's red. What color is it on this cube? It's orange. That means this position is wrong. Even though these pieces are all orange right now, they should actually all be red. So what do we do? What should we do in this situation? Again, we simply solve the pieces one by one. Let's look for the red pieces. Put a red piece in the upper right corner. Make sure there is no red piece here, then do right, up, left, down, down. Now we've moved 1 red center piece to the top. Right here. There's another one here. Again, do right, up, left, down, down. Now we have 2 red pieces. Let's continue. There's one here. This position won't work. We need to move it to the upper right corner. At the same time, make sure this position is not red, since it has to cross 1 face and move directly from the bottom to the top. We use right, up, left, down, down. 3 center pieces are done, and there's only 1 left. Again, we need to adjust it like this. After adjusting it, do right, up, left, down, down. And there we go. We've turned the 4 orange centers from before into red. Of course, my situation here is a rather extreme example. You may not encounter exactly the same situation when solving your cube. The main point I want to show you is that the centers we solved must have exactly the same color arrangement as a 3x3 Rubik's Cube. Let's compare them now. For example, white is on top, and blue is in front. The left side is red, the right side is orange, and the back is green. Yellow is on the bottom. Exactly the same. Only then can we say that the centers of our 4x4 Rubik's Cube are correctly solved. If you finish the centers and find that the colors don't match the 3x3 cube, then you've solved them incorrectly. The mistake is usually made while solving final to center faces. So make sure you pay attention to this. That's it for today's lesson on solving the centers of the 4x4 Rubik's Cube. Now you can start practicing and give it a try. In the last lesson, we learned how to solve the center pieces of the 4x4 cube. Now, take a look. What is still different between this 4x4 cube and a 3x3 cube? And after that snap of the fingers, doesn't this cube look exactly like a 3x3 cube now? Let's look at this face. The center is yellow, and the edge below it is also a yellow edge. The only difference is that the edge on a 4x4 looks longer, right? That's because it's made up of 2 smaller edged pieces with the same colors. Same thing applies here: blue, orange, and green, and the corner is white, green, and blue. So in this case, this face is exactly the same. Let's check the other faces. They're exactly the same as well. Everything matches perfectly. So now we can say that the 4x4 cube has been successfully reduced. It has basically become a 3x3 cube. Just a little bit thicker, okay. And now, everyone should understand the idea. After solving all the center pieces of the 4x4, our next goal is to pair up every 2 edge pieces with matching colors. For example, this yellow-blue edge and this yellow-blue edge can be paired together to form New yellow-blue edge. Our goal is to turn every edge into a pair like this. Let's get started. Let's use these white-red edges as an example. We have one white-red edge on the left and another identical white-red edge on the right. One is on the left and one is on the right. As long as we position two matching edge pieces like this, we can use one algorithm to pair them together. Let's give it a try. For this algorithm, first step is to turn the top two layers to the right once. So we're moving two layers together. And we do our U. These moves are all single layer turns. And U also turning one layer at a time. R, and down. And turn the top two layers back. And now you'll see that these two matching edge pieces have been paired together. They form a brand new white-red edge. Amazing. Some of you may be wondering, but you happen to have one on the left and one on the right. What should I do if I get them in a different position? Let's use these white-green edges as an example. We have one white-green edge here, and let's find the other white-green edge. It's right here. We want to position them on the same layer, with one on the left and one on the right. This one is on the left, so let's move this one to the right. We'll turn it into the right layer, and bring it down into the middle layer. Now, two white-green edges are on the left and right. So what do we do now? We can turn the two layers to the right. And R, U, and down. Finally, turn the two layers to the left, and now the two white-green edges are paired together as well. Let's look at another example. This time, let's look at a more extreme example. For example, we have a yellow-orange edge here. And the other yellow-orange edge happens to be right here. Let's change the situation a little. Let's say it's like this. We found the first yellow-orange edge here, and we've placed it on the left. The second yellow-orange edge is here. It also needs to be moved to the right first, because this piece is on the left. We first need to move it to the right, and bring it down from here. Once we bring it down, you'll notice that these two pieces are one on the left and one on the right. They're not on the same layer, right? One is on the second layer and the other is on the third layer. In other words, they're not aligned. So what should we do? We can remove the first and last steps of the previous algorithm. Let's do our U, and down. Now, two pieces are aligned. They're both on the third layer. Now we can turn the two layers. And R, down, and turn the two layers back. And now they're paired together. That's basically how we pair all the edges. As long as we can find two pieces with the same colors, one on the left and one on the right, we can directly use this algorithm. Some of you may have another question. What if the two edge pieces are on the left and right? They're both near the bottom. Here, the yellow-green piece is on the right, and the other yellow-green piece is on the left, but they're both down here. Can we still do it? Yes, we can. The algorithm stays the same. Turn the two layers to the right, and R, down, and the two layers back to the left. This time, the paired yellow-green edge will appear on the left. It will end up right here on the left. If we keep repeating this process and pair up all of the edge pieces, the cube will have effectively become a 3x3 cube. And we can solve it using the normal 3x3 method. Let me give you one final example. For example, we have a green-orange edge here. We'll place it on the left, and the other green-orange edge is here. Some of you might say, why do you always use examples where the pieces are on the top layer? Can't they be on the bottom? Of course they can. Let's take a look. For example, this green-orange edge is here on the left, while the other green-orange edge is on the bottom. This one is currently on the left, so we need to move this one. Without moving this one, move this edge piece to the right, and make a new move. Now they're positioned one on the left and one on the right. The important thing is to check whether the two pieces are on the same layer after positioning them left and right. As you can see, they're on the same layer. If you encounter a case where they are on different layers after being placed left and right, we simply do this with the right piece. Down. Now they'll be on the same layer. Once they're on the same layer, we use the edge pairing algorithm. Turn the two layers to the right. Then down, and turn the two layers to the left. And now the pair is solved on the left. Amazing. So this is how we solve the edge pieces of the 4x4 cube. I think this method is actually quite simple, and it's definitely easier than the centerpiece method from the previous lesson. So now it's time to practice. Hello everyone. In this video, we're going to learn about the special cases you may encounter when solving a 4x4 Rubik's Cube. After learning the reduction method for the 4x4 cube in our previous video, we can basically treat this 4x4 cube like a 3x3 cube and solve it the same way. However, some of you may find that during the solve, you can run into some special cases that cannot be solved using the normal method. So that's what we're going to cover today. Once the reduction is complete, we can solve the cube normally. For example, we can start by making the yellow-white flower. Or some of you may use a different 3x3 solving method than I do. Either way, the general process is the same. First, we treat the 4x4 like a 3x3 and solve the first two layers. At least during the first two layers. We won't encounter any special cases, so we can solve them quite easily. So I'll skip ahead and solve the bottom two layers. Once the first two layers are solved, the first special case can appear when we make the yellow cross on the last layer. Let's take a look at this situation. Here we have one yellow centerpiece and one yellow edge piece. But none of the others are yellow, right? This pattern is impossible on a 3x3 cube. We know that when making the yellow cross, there are three possible cases. The first is the dot, the second is the L shape, and the third is the line. But this one is none of those, right? Okay, let's try a normal move sequence first. We'll do the yellow cross algorithm, R, U, R, U. And now we have the center plus three yellow edge pieces. The last edge piece is right here. It's in the wrong orientation. At this point, we really can't solve it using the normal method. We have to memorize a special algorithm to solve this group of edge pieces. This case is called OLL parity. So the algorithm used here is called the OLL parity algorithm. Let's demonstrate it. First, place the incorrectly oriented edge in front of you. Then perform the algorithm. Turn the right two layers upward. Then do R. Then rotate the whole cube upward by one layer. Then turn the right two layers upward, R, and again turn the right two layers upward, R. Turn the right two layers downward, R, then turn the right two layers downward and the left two layers downward, R. Right two layers down, R, right two layers up, R. Right two layers down, R, right two layers down. And now you'll see that the yellow cross is solved. So this is our first special case, OLL parity. Now we can continue solving the yellow face without any more problems. Next, we solve the corners. I'll skip over this part as well. Let's just solve all the corners. Once the corners are solved, we may encounter another special case. Looking at the four side faces, two of them may already be solved. Here, the red and orange faces are solved. But the blue face and the green face on the back are not solved. Another possibility is that the red and blue faces are solved, while the orange and green faces are incorrect. That can happen as well. This is another case that cannot occur on a 3x3 cube. We'll call it PLL parity. On a 3x3 cube, we can have either all four side faces incorrect or one face solved, while the other three faces are incorrect. So this is a special case. Let's demonstrate the PLL parity algorithm. For the PLL parity algorithm, turn the second layer from the right upward twice. Then do R. Turn the layer on the right twice again. Then turn the top two layers with R. Turn the right layer twice again. Then turn the top layer and this layer together with R. And just like that, we solved this case. The cube is solved. Now some of you may be wondering, what about the other case? Let me demonstrate that one as well. Okay, let's look at this case. The corners are solved here as well. The red face is solved and the green face is solved. The orange and blue faces are incorrect this time, the two solved faces are adjacent. For this case, simply place any incorrect edge facing the front. Then perform the PLL parity algorithm. Let's do it. U, R, U, double layer R, U, double layer R. After performing the PLL parity algorithm, we'll see that the case has become a much more normal one. Now one of the four side faces, the green face, is solved. While the other three faces are incorrect, this is a normal 3x3 case. So now we can simply use the 3x3 solving method you've already learned to finish solving the cube A. And that's the final video in our 4x4 Rubik's Cube series. If you enjoyed it, please like, share, and send it to anyone who still doesn't know how to solve a 4x4 cube. If you've already solved your 4x4 cube, take a picture of your solved cube and post it in the comments. Thanks everyone for your support. See you in the next video. Bye bye. After completing the entire yellow face, our next goal is to make sure every side has a pair of eyes. You may not have heard of this before, so let me explain what an eye means. If the two top layer corner pieces have the same color, then we call them eyes. If their colors are different, they are not eyes. For example, on the front face, one corner is green and the other is orange. Since the colors are different, they are not eyes. These two, however, are eyes. They are both blue, so these two corner pieces form an eye. Our goal is to make all four sides have eyes. Every side needs to have a pair of eyes. When you find a pair of eyes, place them on the back side. Put them on the back. Then we can perform the glasses algorithm. Let me demonstrate the glasses algorithm. First, perform the right hand move 3 times. R, U. That's 3 times. R, U. Then turn the left side upward once. Next, perform R, U once. Then bring the left side back down. Finally, perform R, U twice. After doing this glasses algorithm, you'll see that every side has a pair of eyes. We have red eyes, blue eyes, orange eyes, and green eyes. This is the glasses algorithm. Let me show you how to remember this algorithm. There is a simple mnemonic, 3-1-2. What does that mean? First, you perform the right hand move 3 times. Then turn the left side up. Now what comes next? 3 minus 1 minus 2, right, now we do 1. So we perform the right hand move once, then bring the left side back down. And what comes next? 3 minus 1 minus 2, right, now we do 2. So we perform the right hand move twice. That's the glasses algorithm. Now, sometimes we may encounter a special situation. For example, with this cube, there are no eyes on the front. None here, and none here. In other words, after completing the yellow face, none of the 4 sides has eyes. In this case, we can simply choose any side and perform the glasses algorithm once. After that, one of the 4 sides will definitely have a pair of eyes. Let's try it. Right hand move 3 times. Then turn the left side up. Right hand once, left side down, then right hand twice. Okay, we're done. Now let's check where the eyes are. None here, none here, none here. Here we have orange. These orange corners are the eyes we're looking for. So we can take these eyes and place them on the back, then perform the glasses algorithm again. 3, left side up, 1. Left side down. 2. Okay. Now every side has a pair of eyes. In the next lesson, we'll learn how to adjust the final few edge pieces. Once you learn that, you'll truly know how to solve the Rubik's Cube, so you can start practicing now. If you're getting comfortable with it, click the playlist below to watch the next lesson, the final step of solving the cube A. After completing the yellow cross, our next goal is to complete the entire yellow face. At this point, this is the only time we put the yellow center on the bottom. Once it's facing down, we only need to focus on the bottom right corner. We can determine whether this corner is correctly oriented by looking at the direction of the yellow sticker. For example, if the yellow sticker on this corner is facing you or facing right, then this corner is incorrectly oriented. It is only correct when the yellow sticker is facing downward, meaning it is facing the yellow center. The one I have here is obviously in the wrong position. When it's wrong, we do the right-hand algorithm twice. R, U, R, U, R, U, R, U once, and R, U, R, U twice. After doing it twice, let's check. Now this corner is solved. As you can see, the two white layers we solved earlier have now become scrambled. Don't worry about that. Once we solve all 4 corners, the entire cube will be solved. Now that we've solved this corner, we move on to the next one. Let's move to the next corner. When changing corners, there is one very important thing to remember. You can only move to the next corner by turning the bottom layer. Only turn the very bottom layer. You must not say, I've solved this corner, so I'll just rotate the cube, like this, and work on another corner. That definitely won't work. After solving one corner, we can only turn the bottom layer to change corners. This is very important to remember. A lot of people make mistakes at this step. Okay, after moving to the next corner, we can see that this corner is still wrong, so we do R, U twice. After doing it twice, we can see that it's correct, so let's move to the next corner. This corner is not correct, so we do R, U twice. After doing it twice, you'll see that this corner is still wrong. What should we do? Do R, U, R, U, R, U, R, U. Okay, now this one is solved too. Let's move to the next one. R, U, R, U. Do it twice and check. This corner is still wrong, so we do R, U twice again. And now the entire yellow face is solved. Some people may run into a problem here. For example, let's say this is my last corner. I do R, U twice, and the yellow face is solved, but the whole cube is scrambled. So what could have caused this? One possibility is that when changing corners, you didn't turn the bottom layer. Instead, you rotated the entire cube. The second possibility is that there is actually something wrong with your cube. So what should we do? We can continue doing R, U, until the first 2 layers are solved again. Then take a look. If you find that only one corner is wrong, then there is a problem with the cube itself. Simply twist that corner back into the correct position. Okay, now you can start practicing. See you in the next video. Bye-bye. Alright, we've now reached the final step of the entire 3x3 Rubik's Cube tutorial. This step is actually a little easier compared to the previous steps. So first of all, congratulations on learning how to solve a 3x3 Rubik's Cube. And I hope you can support me as well. You can follow the channel and give this video a like. And feel free to share and leave a comment. Thank you all for your support. Alright, now let's get back to the tutorial. Once we've solved all 4 pairs of eyes, most of the time, besides the white and yellow faces, we will have one completely solved face. It could be blue, red, green, or orange. In my case, this face is blue. It's already solved, so let's put it facing us. Then we can directly perform the solving algorithm. Let me demonstrate the algorithm. Do the right-hand algorithm 5 times. Right, up, left, down. 1, 2 times. 3, 4 times. 5 times. Some of you might say, this is hard to keep track of. How do I know how many times I've done it? Just remember that after 5 times, a small white square should appear on the right side. A little white ear will appear right here. If it doesn't appear, you haven't done it 5 times. You may have done too many or too few. You can use this to check how many times you've done the algorithm. Alright, after doing the right-hand algorithm 5 times, let's do the left-hand algorithm 5 times. Right, up, left, down, 1 time. Right, up, left, down, 2 times. 3 times. Right, up, left, down, 4 times. Right, up, left, down, 5 times. When it appears, that means you've done it 5 times. Next, we do the right-hand algorithm once. Right, up, left, down. Then the left-hand algorithm once. Right, up, left, down. After doing that, you may notice that the other 3 faces don't seem to be solved. So what do we do? Don't worry about it. Sometimes one round of the solving algorithm is enough to solve the entire cube. Sometimes it isn't. In that case, we simply do it a second time. Right-hand algorithm 5 times. The small white piece appears 5 times. Perfect. Then the left-hand algorithm 5 times. Right, up, left, down. 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 Great, done. Then the right-hand algorithm once, and the left-hand algorithm once, and the entire cube is completely solved. Now, don't rush off to solve your cube yet. Don't rush, let's finish watching the video first. Sometimes we may encounter some special situations. For example, like this. We have all 4 pairs of eyes solved on every face, but not a single face is completely solved. Earlier, I said that most of the time we would have one solved face, but sometimes that just doesn't happen. Life isn't always perfect, and the Rubik's Cube is the same, right? There's simply no completely solved face. So what do? We can choose any face and directly start the solving algorithm. Okay, right-hand algorithm 5 times. Left-hand algorithm 5 times. Right hand once, left hand once. After doing the solving algorithm once, we can see that although none of the 4 faces were solved before, now we have one completely solved face. So we keep this solved face facing us and perform the solving algorithm one more time. Right-hand algorithm 5 times. Left-hand algorithm 5 times. Right hand once, then left hand once, and the entire cube is solved. If it's still not solved, simply perform the solving algorithm one more time. And finally, let me teach you an easy way to remember the solving algorithm. The shortcut is simply 5511. 5-5-1-1. Just remember it this way: right hand 5 times, left hand 5 times, right hand once, left hand once. That's the solving algorithm. And once again, congratulations on learning how to solve the 3x3 Rubik's Cube. Once you've solved your cube, you can take a picture of it and post it in the comments. You can also share it with everyone else if you run into any kind of problem. Those who have already learned how to solve the cube can help those who haven't. If someone is having trouble, help them figure out what went wrong and why their cube wasn't solved correctly. I hope everyone can have a friendly discussion in the comments. In the next video, we'll probably move on to tutorials for other types of Rubik's Cubes. See you in the next video. Bye bye.